So for our next ditty here comes the terms. There's a lot of them. Again, you can hear of several that are the same, but I really try to pinpoint. You're going to hear me use range, preimage. Actually, you won't hear me use preimage and image all that often, but you will hear range. So I'm very consistent in these set of notes. Again, your other resources that you may look up, they may not be consistent, so just a heads up on that. Same image, same blob as we had before, but a couple different things here. Number one is image. So an image is usually using a specific call. There's an individual and then there's the as a whole. But individually, you're using a specific call like f of 1 here, where it's going to retrieve a certain value from y, a very specific value. That is the image, singular, individually set up image for a specific set of a function. But as a whole, for all the possible calls of f of x, it's going to return the set of all of the different values that are in y that we can reach. Now, by the way, notice, I'm going to call that the Bermuda Triangle, which you guys are so young, probably don't even know what that is. But anyway, in the codomain, there is going to be a portion in some functions where we just can't reach. We'll go over that here in a little bit. The range, which is our next item in here, our range is what values can our function reach within the universe of all of the capital Y values that are in here. So again, this range is not always going to be the entire codomain. There may be some values that we're not going to be able to reach that are legitimate Y values, but the function just doesn't have that capability of reaching that portion. So you're going to see values end up in here eventually. So just keep an eye on that. To give you a very specific setup where you're going to have codomains, you're going to have codomains that are not within the range of the function, is using f of x equals x squared. You know that 2 squared is going to equal 4. You know that 0 squared is going to equal 0. You know that negative 4 squared is going to end up 16. So what about all the negative, I'm not even done yet. By the way, negative numbers, we know they can't reach that. But the kicker is that there's some positive values that also can't be reached, like 2, 3, 5, and 6. They just can't be reached by this function. So the range is really what all of our answers or solutions are going to be from the given function that we have. There's a couple of things in here as well. Number one, notice that usually we're giving what the x set of possible values are going to be. Now, capital X set of values are going to be. So these are going to be all integers. Notice, all integers. All those in the domain. But for our y, notice that all of our real values that we're going to have in there are going to be integers, but they're going to be positive integers for our range of possible values for this overall function. So here's a setup in y. There's a difference between what we can have in a codomain and what's in the range. Here's putting all of those terms together in basically an exercise or something of that nature here. So notice, by the way, in this, we have a range that is definitely different than the codomain. It's within it. It is a set within the codomain, but D and E are two values that we just can't reach in this particular function, whatever it was. So when we do our image here, we do f of 1, we go to 1, and then we see that it's going to end up mapping to our b. So I think you can understand that first line. The image b is the image of 1 under f of a, b, and c. Notice, by the way, I didn't say D and E, even though they're options, but they were never really part of it. The image of f. In the pre-image, 1 and 3 is the pre-image of b. So what does that mean? Well, b can actually access 1, and if we did an inverse, it could, for some reason, access 3. So that's our pre-image. But again, notice our range. Our range is not our entire codomain here. It is just those 3 values that we have as legitimate solutions for whatever function that we would have been using for this particular block.